All right, let's look for a proportion of a hypothesis test. So a genetic experiment involving peas yielded one sample of offspring consisting of 444 green and 140. Use a 0.01, so that's my alpha significance level, to test the claim that the same circumstances, 23% of offspring peas will be yellow. So this is what they're telling me, my population. Identify the null alternative, test stat, p-value, and then the conclusion. So the null and alternative go hand in hand. Once you know the null, you can certainly write the alternative. This says they will be. It doesn't say they'll be less than or greater than. So when something will be equal, then the opposite for the alternative would be not equal. So my proportion, this says 0.23 or 23% of the offspring will be yellow. This says they will not be. All right, let's find the test stat. If you 0.2, you saw that we've used this before, where the p hat is 140 of the yellow out of the total. So this 584 is the green plus the yellow minus my population, and then divided by p times q, which is 1 minus p, divided by the sample size, and you get 0.56. There's certainly a much easier calculator. I mean, it's nice to go through an example by hand so you understand what your calculator's doing, but this, you just hit the stat button, test, arrow down to one proportion z-test, and then you put in your population, you put in your x value, you put in your n. This test is a not equal, and you hit calculate, and it also even gives you the p-value as well. So not only do you get your z statistic, but you get the p-value, which is really, in this case, if they ask for a p-value, this is easier to use, but the printout will give you your z. All right, the conclusion, to find the conclusions is to look at the p-value compared to the significance. The p-value is definitely greater than, so this p-value is the probability that we would expect to get this value. If it's very, very high, then we would fail to reject the null because we would expect to get about 23%. So then we conclude there is not sufficient evidence to warrant rejection of the claim that 23% of offspring will be yellow.